So we finished, what's going on here? There we go. We finished a few weeks ago. We were doing a lot of work with graphs of straight lines. And what did we do? We talked about the rule that makes a graph. We talked, so representing it with a rule. And we call these things relations, right? So representing a relation with a rule. And a relation is a fancy way of saying like a pattern. Remember when we very first started talking about this stuff? Excuse me. What did we talk about? We talked about blocks and the growth pattern of a picture of blocks. And so you could make like a picture with blocks, and that picture would grow every figure number. So figure 1, it looked like this, figure 2, and there was a pattern, and we saw how that pattern grew. But otherwise, the blocks were generally the same kind of picture every figure. You understand what I'm talking about, right? So we started talking about that. And so that's just a pattern or a relationship, or you could think about it as a picture of blocks, like you could think about it that way. And so what did we do? We talked about the rule for the relation. We talked about the table for the relation. We talked about the graph for the relation. And we practiced moving between all three forms. So if I gave you a table, you could give me the rule and the graph. If I gave you a graph, you could give me the table and the rule. If I gave you the rule, you could give me the table and the graph, right? So we could kind of go all different directions. Familiar enough to everybody? Then we took a little break. Last week was a crazy week because of all the literacy test and everything. And we did our midterm, and like I said, that went very well. And so now what we're doing is we're diving back into the same kinds of straight lines, which we call linear relations. Remember we talked about linear, when something's linear, when it's not linear. But from now on, almost always at least, it's not just about numbers in math class. We're going to be talking about something in the real world. And it's nice because you can use your intuition and your knowledge of the real world to make sense of the math. So I think a lot of people will really like this. Some of it will get a little bit more complex than what we've done so far. So we'll get a bit deeper into it, which is really nice. But the whole time, we're going to see the power of linear relations and how common they are in simple day-to-day interactions that we have in the world. A lot of what we do, we'll talk about costs, we'll talk about money, but not everything. There's other applications, absolutely. Some of them with speed, we're going to talk about, you can see here, or distance, or that kind of thing, okay? And remember, a lot of what we do in this course is giving you the opportunity to build your own strategies or come to terms with which strategies you like, make your own connections. As I was writing report cards up over the weekend, I always like that process because it makes me reflect on what, you as a student individually, but students in general as well. Because when I write your comment, I think about you individually and what makes you successful. When are you successful? When are you not as successful? What are your strengths? That kind of thing. Or some people might like to do questions one way and other people like to do questions a different way. And that's fine, right? And that's the reflection that I go through when I write up report cards and report card comments. And one thing that I thought about and I found myself writing a few times was make sure that you are taking the time to build your own strategies, that you are reflecting on what makes you successful. I did this question this way and got it wrong. I did it this way and got it right. I think I like this way better. Make sure that as you're practicing, you're checking your answers. Because if you're using a strategy and you're solving questions a particular way, but you're getting them wrong, that strategy is not working. And the only way you're going to find out is by checking your answer. Whoops, I got this one wrong. And then you either look back at maybe we did an activity together where there's an example, or maybe it's still up on the board that you can follow, or you put up your hand and say, sir, I'm getting these wrong. Can you help me? Can you remind me what I can do to get these right? Or where am I going wrong, or whatever, right? But make sure that you are going through that reflection of when you're right, when you're wrong, and which strategies are working and which are not. That's your job. And you got a long time to do it. So we're going to get back to linear relations probably tomorrow. I don't know. I don't have the stuff in front of me. I think maybe tomorrow. But for now, we're actually just going to talk about something different. It's obviously related. It's a big part of it. But it's one part of the linear relations that we're going to get into. So you remember when I said over and over and over again, what are the two important parts of a linear relation? It's been a while since we talked about that. Remember that though? Everybody's supposed to have the answer. It's this and this. What is it? Give me one. The change, what's the other? Where it starts and what's the change. So today we're just going to kind of talk about one of those things. And which one do you think it is? The change. How do you know? Because of the word change right here. So we also call it, so just so you know, we also call these rates or rates of change. So whenever we talk about the change in the graph, it's the same change as we've been talking about. We're talking about rates. What's the rate is the same as saying what's the change. So when I say what are the two most important things, you might start saying what's the rate. But you could also say what's the change or what's the rate of change. Like it's all the same. You see what I'm saying? Okay. Here we go. Average speed. Somebody give me an example of average, of what speed is. The measurement of speed. What would it be? What does that make you think of? Okay, so how fast? What else? If you're in a car, what would be your speed? Okay, so distance, very nice. Over time. So how far over some amount of time? Maybe it's a minute. Maybe it's 10 seconds because it's like a 100-meter sprint in the Olympics. Maybe it's an hour because you're driving to grandma's house. I don't know, right? Or you're driving to Toronto or something like that. So the time can change and the distance can change, but it's a relationship between distance and time. That's really important. What else? What do you think about speed? Approximately how fast would you drive in your car? Who can tell me something about that? Miles per hour. Or in Canada, kilometers per hour. If I'm driving on a town road, does anybody know? I know you don't drive, so it's a little bit harder, but what's a typical speed limit? Probably faster. 30 miles per hour, definitely. 60, 50 to 60 on roads. Around schools, it's 40, right? So 50 to 60, that's in the city. On a highway, like the 401, it's 100 kilometers per hour on the 401. Okay, so different speeds. If I am driving 50 kilometers per hour for 2 hours, how far do I go? If I'm driving 100 kilometers per hour for 3 hours, how far do I go? Like these are the kinds of questions you could talk about, you could think about when you're talking about average speed and rates of change. If I drive 200, well, I'm running out of space here. If I drive 200 kilometers in 2 hours, what's happening? 100 kilometers per hour, 100 kilometers each hour on average. That's what average speed means. That's exactly what Ashton was talking about, is like it's a relationship between distance and time. Does that make sense? Yes? Everybody okay with that? So let's take a look. So this is important. Take a look at this graph. This is distance. Something that's really important for everything that we're going to do for the next little while is when you're looking at a graph that you look at what's the label here? Okay. What are the units? And what are the units there? So when I look at one of these lines, so for example, let's say I look at this point. It's 200 kilometers, and it's in 1, 2, 3, 4, 2 hours, like we were just talking about. 200 kilometers in 2 hours. So I'm going to call this line A. Whenever we have more than one line in a graph, it's a good idea to give them some kind of a name or label so we know what we're talking about. So A is 200 kilometers in 2 hours which is 100 kilometers per hour. Make sense? You like that? This is going to be important later on. So I'm going to tip my hat a little bit here, or tip my hand a little bit to you here. This was starting at 0, wasn't it? So the distance that I traveled went from 0, where it started, up to 200, because that's the point that we picked. And it started at 0 time in hours and went to 2 hours. So the total change was 200 over 2. It's not just this point that I chose. But let me take a look at another thing and just watch for a minute. What if I chose this point? Would I get the same answer? 300 kilometers in 3 hours. Do you agree that's the same answer? What if I chose this point? 500 kilometers in 5 hours. Same answer. So it's a straight line. It's got to have the same rate across that entire line. That's what a rate means. Does that make sense? Doesn't matter which points I pick or where I go on that line. If I do it correctly, I'll get the same answer for all of them. Any questions so far? Okay, let's try the next one. What if I pick this point? So we'll call this B. How far did I travel in this case? 200 kilometers this time. That's right, which is the same as the last time. And look, put your pencil down or put your heads up and watch. See, look, same. Right? Same distance. But they're not going to be the same average speed, right? So 200 kilometers, because as Noah said, this time it was in 4 hours. So if I go 200 kilometers in 2 hours and you go 200 kilometers in 4 hours, like what's the difference between us? We've both gone the same distance, but it took you longer. So you're traveling what? Total, this case, is 50 kilometers per hour. How'd you get that? Nice. So he looked at the last question and just thought it's double, so it's going to be half the speed. Good. What would be another way that I could have solved it? Anybody have another? This is what I'm talking about, strategies. What's another way that you could figure out what the average speed is? No? Yeah, divide. 200 over 4 is 200 divided by 4. And look at this. Again, put your pencils down and watch. The units are kilometers per hour, kilometers over hours. They're in the question, the way I wrote it. So you shouldn't ever have a problem finding units. We're going to talk about units in a moment. But it was kilometers over hours, right? I could just look at it like that, and that's kilometers per hour. And in general, if we go in the same distance, so we've both gone 200 kilometers, but I did it in 2 hours and you did it in 4 hours, you're going slower. So your rate is a smaller number, a slower average speed. These seem like simple ideas, folks, but this is a big deal. And looking at the graph, how is the fact that it's slower represented by the line? We've talked about this before. Right? Oh, very nicely. Did you hear that? The line B is not as steep. So it's a slower rate. You can see it in the graph. That's a big, big connection to make, folks. That's a big, big idea. Okay, last one. What do you think we should call it? Oh, gee, I don't know. How about C? Creative names. C. And if we do the same thing, we might say 200 kilometers again. Why not? But I could use any of these points. So 200 kilometers. But it's interesting to notice that all three of these, we use the same number on top. It was just the bottom that was changing. And in this case, how much time passed? 8 hours. So maybe this time I use this strategy. If you want to watch, 200 divided by 8 equals, and what do I get? I get 25 kilometers per hour. So even slower and even less steep. Yeah. Yeah. I think we could, although, yeah, look at right there. I could have used 4 hours for each of them. Now, I don't have to use the points that I'm given, these dark black points. I don't have to use them. I could use this point here, right? I'm pointing at this one right here. I could pick whatever point. I want to pick a point that I can read properly. So I don't think I want this point, because I'd have to guess. But I could use this point. Or I could use any of the black points. And I could have used 4 hours for all of them. So 400 over 4, 200 over 4, or 100 over 4. And like I said before, that would give you the same answer. 100 over 4 is 25. So it's going to give you the same rates, same average speeds in this case. You could pick whatever point you want. But you got to make sure that it's a nice point that you can actually read. Here's another one. It's not a given black dot. You're going to see some of these graphs don't give you the points. You got to pick nice ones. And by nice ones, I mean we call these lattice lines, where the grid lines are a lattice point, where the lattice lines meet, the grid lines meet. Okay. So average speed is a really nice rate to talk about because it's one we understand very well. We get that if you go farther in the same amount of time, you're going faster, or if you go the same distance in a longer time, you're going slower. Like, we can make sense of that. And this is what I'm talking about for linear relations. You can connect with this stuff. Okay, this is what I'm talking about. But there are other types of units and rates. So if this was the graph, and I don't know, there's no line, but let's say the line looked like this. What would the units of the rate be? Anybody have any idea? Do you have a guess? So what are we going to do? We're going to look at the units and the units. And what would the units of the rate of change be in this case? Anybody want to make a guess? There's an easy way of knowing, but I'm curious if somebody has a gut. Very good. So the slope of the units are going to be dollars per kilogram. Put your pencil down and look very carefully. The way that we always do it is it's the units of the vertical measurement, so the up-down one, the one over here, this used to be y. It's not going to be y anymore. It's going to be something like cost. So we probably won't call it y. We'll probably call it c, but we're not going to worry about that yet. Okay? But it's the one that's going up, down, over the one that's going left, right. So vertical over horizontal. Always, always, always. That's how we're going to do it. So if you can just remember that, you can always get the units very easily. Distance, the one up and down, over hours. So kilometers over hours, which is kilometers per hour. Dollars over kilograms, dollars per kilogram. And that's a more common rate than kilograms per dollar. We don't usually go kilograms per dollar. If you're buying bananas or grapes or broccoli, it's usually dollars per kilogram, right? Okay. So what would this one be? And this is starting to give you a bit of an idea of how these graphs can represent all different kinds of things. Very good. So degrees Celsius per hour. What's that? What would this graph be measuring? What if I did this? What if I said that was my graph? That means like maybe it's overnight. The temperature is decreasing. Right? Or maybe it's during the day, I don't know. But yeah, exactly. So that you can see that the temperature is going down over time. Okay, so thinking about units of rates is really important. And now we're just going to practice calculating some rates. So this one should be called A. We'll start with A. First of all, what are the units? Somebody else. Walker, what do you think? How would I figure out what the units are? Yeah. So it's... Yeah, but just units. I'll get the numbers from you in a second. So what's this one? Yeah, dollars per... So what is that? Yeah, like your job or something, right? Dollars per hour. This is another one that we often see come up. Another type of example. And as you were saying, the number for A, so Walker, you're going to pick this point? Is that what you were thinking? Perfect. So it's $150. And how long was it? Why 30? Oh, 3. I think it's 2, though. Does it look like 2? I think we're going to go with 2. 2 and hours. Very good. Thank you. Awesome. And what is 150 divided by 2? Anybody have their calculator handy? Should have it out, Ken. So $75 per hour. That's pretty good money. $75 per hour is pretty good. That might be like a plumber or an electrician or something like that. Doctor probably makes that much money. Okay. B. Now, there's something tricky going on with B. So put your pencil down and watch. If I pick that point, what happens? What do I get? What is that? You see what that is? On your sheet, don't use mine. It's too hard to see from up there. Don't write this down. I want you to put your pencil down and watch for a minute. Noah? I think it's 50, 60, 70, 80, 90. I think it's counting by 10. So I think it's 80. And that's over 2. Don't write this down. Put your pencils down and watch. One eye's up here. What's 80 over 2? 40, good. What if I picked this point? What's that? 100? And what's that? 1, 2, 3, 4. What's 100 over 4? 25. Do you think it should be a different rate depending on which point you chose? What happened here? Does anybody have anything to say, or does anybody want to make a comment? Okay, a few people have their hands up. That's great. What do you think? It doesn't start at 0. Why does that matter? Okay, so this is a really, really important idea as well. So take a look. Just watch, though. When I used this point, I started at 0, so I made $150 in 2 hours. That was my total earnings. When I choose this point, I'm not making $80 in 2 hours. How much did I actually make? I started here. How much is that? It's 10, I think it's 20. It's hard to see on the screen, I know. But yeah, I think it's 2 lines. So it started at 60 and went up 70, 80. So I've only made $20. So I'm going to get rid of all this because this is wrong. And I'm going to do this. I'm going to actually use, you could use this point, but I'm going to use these 2. Okay? So from here to here is an increase of 2 lines, so that's 20, because every line is 10, right? So I went from 100, I went from 80 up to 100. Actually, let me get rid of that. So I went up 20. And that was in how long? From here to here is a change of how many hours have passed? What do you think? So I started at 2 hours, and now we're going to 4 hours. Like, there's different ways of looking at this. Is that a change of 2 hours? Does that look okay? And what's 20 over 2? 10. So this one's $10 per hour, nowhere near as much. And look at that line, it's a lot less steep. And that was like, what did we do? We kind of did 100 minus 80 over 4 minus 2. We looked at the change. And it's positive 10, it's not negative. Could you have a negative change? Yes. What would that look like? It would look like a line going down on the graph. But this is still earning money. You're not losing money. Negative $10 per hour would be losing money every hour. Don't take a job where you lose money, trust me. Okay? Make sure you're always making money. Everybody okay with this so far? And for C, let's do C. Let's see if you can do C. I want you to try C on your own. Raquel, what'd you get for C, just for the first part? So you got 80. So you picked this point, and you went over, followed across to get 80. Is that right? And? So $80 in 4 hours. How many other people had that too? $80 in 4 hours. And what do you notice about this line? Donovan, what's important about it? It starts at 0. So we only looked at 1 point. What is 80 divided by 4? Who's got an answer to that? Justin? 20? Anybody agree with that? 20, so that's $20 per hour. So again, I want you to just watch, put your pencil down and watch. What if I did this? What if I picked 2 points? It's always safe to pick 2 points. If I only use 1 point, I could get myself into trouble if it didn't start at the origin. Or if it didn't start at 0, sorry. It's called the origin, right? But I can always use 2 points. So this was an increase of 10, 20, 30. Is that right? 10, 20, 30, $40 in 2 hours. What's 40 over 2? 20. Same thing, right? So in this case, I can use 1 point because it started at 0. But I can always use 2 points, and sometimes I have to use 2 points. Remember for line B, if we use 1 point, we get the wrong answer. All right. I want you to try this one again. Try question B. There's only 1 line, so you don't need to give it a name. See if you can figure out the rate. How many people have an answer, something at least for B? Okay, I saw a couple of answers that I like. Brandy, can you tell me what you wrote? 150 divided by 5, which is 30. And did you give it units? You said kilometers, but what did you say? So kilometers? Very nice. So we notice that this one's kilometers per, oh, the thing is kind of weird. It should be up here. That's just a mistake on the sheet. But kilometers per hour. Awesome. And take a look. The change went from 150 to 0. And it took 5 hours to do that. So that all makes sense. Ashton, what did you do that was kind of different? Like you looked at it a different way. So what did you do? Can you explain? Right, so look, you go over 1. This is what you mean, right? Tell me if this is what you mean. Every time you go over 1, you're going down 10, 20, 30. Over 1, 10, 20, 30. Over 1, 10, 20, 30. Over 1, 10, 20, 30. And so what did you do to represent the down part? So it's negative 30 kilometers. This is what we were talking about, right? This is important. So it turns out that's a really important idea that if the line's going down, that the rate is negative. What does that mean in this case? I don't know. It may or may not be important. Maybe it means you're starting 150 kilometers away and driving towards your house. So the distance to your house is getting smaller. I don't know. And you're driving really slow because you're stuck in a lot of traffic. And then think about that. Like when this way that Ashton looked at it with the sort of stepping down shows how all of this makes sense. If every hour I'm traveling 30 kilometers, in 5 hours, how far will I travel? 150 kilometers. It all matches. Ashton's answer matches Brandy's answer. Very good. Okay, the last one. What's going on in the last one? Yep. So apples per box. Does that make sense as a rate? Maybe if you're a shipping company or you're a grocer, you have big boxes and smaller boxes. You can fit more apples, so you're going to charge more for a bigger box. I don't know. But this makes kind of sense if you think about it, right? Apples per box. And notice how we always use that per idea for a rate. What's different about this one from some of the other examples that we did? Marley? It doesn't give you the dots. So you got to pick them yourself. So for the first one, I'll help you with the first one. I'm going to pick this dot and this dot. You got to pick nice dots. You got to pick nice lines. What was the change here? How many apples? 50. So for A, I've got 50 apples. And what was the change in boxes? 1. So 50 over 1, which is 50 apples per box. So box A can fit 50 apples per box. That means if I have one box, I have 50 apples. If I have 2 boxes, I have 100 apples. If I have 3 boxes, I would have 150 apples. 50 apples per each box. All right, I want you to go ahead and try B and C. And we're not going to do example 4 for now, so we'll leave that one. B is a little bit trickier because I don't think it has as nice a point. So here's what I'm going to do. If you want to watch, I'll start here. I'm just going to follow up. Oh, there's one. That looks like a nice point. 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 See how I can, if I just follow along the line, but I don't want to use any of these ones in the middle. So what are the different points that I could use for B? I could use this, 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 and this. And I can pick any two. Oh, I picked two bad ones here. What am I thinking? Okay, so this is 90. This is 150, 160, 170, 180. So that's from 90 to 180 is a change of what? How much did I go up? How am I going to figure that out? It's 90. How do you figure that out? You just kind of know it. I could do 180 minus 90, right? So this is plus 90. And this was 3. And this is 6. So that's a change of what? 3. So plus 3. So for B, I've got a change of 90 over 3. And what is that? 30 apples per box. Smaller box. And take a look. If I really wanted to, I could come in here and I could see, look, for one box, it got 30 apples. And that works because it started at 0, so I can get away with that. But remember, sometimes that doesn't. That's something we'll continue to talk about. Okay, I want you to try C. Could do the same thing. What did you get for C? C might be harder because I can't pick 1. It's not a good point. So I have to go up. So I could start at 2 and I could go to 4. So from 2 to 4 is plus 2. And what was my change here? I went from 10 to 20. 10, 20, 30, 40, 50. It's really important that you figure out what the scale is counting by and you look closely and you've got that. So that is plus 10 apples over 2 boxes. So 10 apples in 2 boxes is 5 apples per box. So a very small box and a very not steep or shallow kind of line. Does that make sense?